Professor.
Oh, we are disturbing you early morning. Okay.
I'm still sleeping, but it's okay.
Yeah. So thank you for your coming, sir.
Very, very nice to meet you.
Yeah, thank you. So another 5 to 10 minutes, we start the program, Professor.
Professor.
Yeah, I'm able to hear.
A very good morning and
well,
morning,
for me it is good evening.
Yeah, good evening, Professor. Thank you so much. Thank you so much for coming, Professor.
You are most welcome.
At last we achieved you to bring here. Last time we failed to join for our conference, Professor. This time we succeeded. Yeah, thank you. Many of the people are ready to see your talk via YouTube link also, Professor.
Okay.
Parallelly, the stream is going on. Our chairperson of our School of Mathematics is willing to talk with you.
Professor, good evening, Professor. Welcome.
Good evening. Good evening.
I'm Dr. Anbalagan, head of the Department of Mathematics, Professor.
Okay, nice to see you.
Thank you. So another 5 minutes, the Vice Chancellor will come, Professor.
It's okay.
We will start immediately. Okay.
And Professor Nadesan Srinivasan is there, Professor. He is on the way to join with us.
Okay.
Yeah. How is the situation going on there in your place, Professor?
Well, last 9 months, we are just sitting in the house.
Yes, Professor.
So everything, teaching, everything is from the house.
The house only.
Yeah. Why I recorded this lecture, because tonight, at 3 places I am supposed to give the lecture.
Okay, Professor.
Dr. Raj, I am here.
Professor, very good morning to you, sir.
Very good morning.
Thank you very much for joining with us, sir. Professor, our Vice Chancellor is there, sir.
Good morning, Professor Agarwal.
Good morning.
Nice to meet you.
But your half picture is coming.
I'm sorry, very inconvenient hour we have hosted this for you.
No, it is okay. What I am saying, your half picture is coming.
Yeah.
I'm sorry. Okay. Sure, just...
Maybe you need to go back a little.
Yeah, why not? Yes. Or you need to see me.
That's perfect. That's perfect.
Thank you.
Can you see my picture?
Yes,
absolutely.
Yeah,
okay. Nice.
Clear, neat and clear.
So I would like to thank all of you. And my PhD is from Madras. So I was in Madras for 4 years, and then I was in Tiruchirappalli for three years.
Oh.
So I know South quite well.
Okay.
Anbalan sir, start பண்ணலாமா sir?
Professor, start பண்ணலாம் sir. Rajendran sir.
Okay, can I just a few words?
Yes.
Sir, formally, I will welcome you, sir.
Okay, go ahead.
Very good morning to one and all present here. So, National Mathematics Day is celebrated on the 22nd December of every year. It is celebrated to mark the birth anniversary of legendary Indian mathematician Srinivasa Ramanujam and his contributions in the field of mathematics. He had never been formally trained in the subject, yet he became one of the greatest mathematicians of all time. Our former Prime Minister of India, Dr. Manmohan Singh, paid tribute to Srinivasa Ramanujam at a function organized on the occasion of 125th birth anniversary of the great mathematician Srinivasa Ramanujam in Chennai in 2012 and declared 22nd December as a National Mathematics Day. Thus, on 22nd December 2012, National Mathematics Day was celebrated across the country for the first time. So we are all gathered here to celebrate the legendary Srinivasa Ramanujam birth anniversary as a National Mathematics Day today. So on behalf of the School of Mathematics, I request our chairperson of School of Mathematics, Dr. N. Anbalagan sir, to formally give the welcome the gathering.
Most respected Vice Chancellor, Professor N. Rajendran, distinguished Chief Guest, Dr. Ravi P. Agarwal, Professor of Mathematics, Texas A&M University, USA, and other faculty members from all over the country, participants and my dear students. Good morning to one and all. So rightly pointed out, Professor Raja, it was declared by our former Prime Minister, Dr. Manmohan Singh, on the 125th birth year of Ramanujan, Srinivasa Ramanujan Iyengar. It's marked as a National Mathematics Day. On the same day, that is December 22nd, 2011, our Ramanujan Center for Higher Mathematics building also opened, declared by our former Prime Minister, Dr. Manmohan Singh, the same day, the year 2012. So with this, I'm happy to welcome Professor N. Rajendran, Vice Chancellor of Alagappa University. Professor N. Rajendran has been a founder director of Bharatidasan School of Science, Director and Center of Distance Education, and Dean of Faculty of Arts. Further, he is a member of Board of Studies in 10 various institutions and universities, prestigious institutions. Professor N. Rajendran served as General Secretary in Tamil Nadu History Congress from 2007 to 2017, and the General Secretary in South Indian History Congress from 2015 to 2017. And the General Secretary in he is the only academician to hold this prestigious position of General Secretary of two premier history associations simultaneously. He is a lifetime member of Indian History Congress. He has been member of research boards in 5 universities, various universities in Tamil Nadu. And also he has been honored with prestigious membership in the Indian Council of Historical Research, the apex funding body for historical research in India, which is awarded by Ministry of Human Resource Development, Government of India. Professor Rajendran has received the Best Book Award and honored with a title Sindhanai Peroli for his book Tamil Nadil Desiyam and Svedeshiyam. Citation of meritorious achievement and achiever, he achieved many things. I read out a few of things. Under his able guidance, the Alagappa University also achieved many milestones. With this few introduction, I welcome Professor Rajendran to preside over this discussion. Welcome to you, sir.
Thank you. Thank you, Dr. Anbalagan.
Yes, sir. Next, I welcome the distinguished Chief Guest, Professor Ravi P. Agarwal, Professor of Mathematics, Texas A&M University. He is also a very eminent mathematician. He achieved a lot of awards, various achievements in research and also the teaching field. Professor Ravi P. Agarwal was born in Ahmedabad, India on July 10, 1947. After completing his schooling, he earned his master's degree from Agra University in 1969. Then he earned his PhD in mathematics at the IIT Madras in the year 1973. Dr. Agarwal has been actively involved in research as well as pedagogical activities for the last 49 years. His major research interests include numerical analysis, differential and difference equations, inequality, point. He has published 45 research monographs and more than 1,700 publications in various SCI's focus in textile journals. And also, he has held several positions, including visiting professor, visiting scientist all over the world. So almost he served all institutions all over the world. And also, he has been ranked as highly cited researcher for 14 consecutive years. And also, he has been recognized as one of the world's most influential scientific minds in the year 2014. In 2020, he has been listed among world's top 2% scientists by Stanford University. Congratulations, Professor, also for this. Dr. Agarwal has received many honors and awards. So the list is very high. So I think that and prestigious one of the prestigious award he received German fellowship also. Apart from that, Dr. Agarwal is research and innovative talks over 100 institutions all over the world. And also he visited many countries. He has served over 40 journals in the capacity of an editor, reviewer, honorary editor, associate editor, and published 20 books as an editor. Dr. Agarwal has organized many international conferences also. So with this I read only few of things about Professor Agarwal. So with this I welcome our distinguished chief guest, Professor Ravi Agarwal. Welcome you, sir, for this National Mathematics Day. Welcome you, sir.
Thank you. Thank you.
Next, I welcome all the faculty members from all over the world. Professor Obidiu Bagdasar from UK, Grigory Rajkot from Thailand, and some of the professors from all over the countries. I would not read all the names. So once again, I welcome all the professors and my dear students and our faculty colleagues. I welcome you all. Once again, I welcome all for this National Mathematics Day celebration. Thank you.
First of all, let me thank Professor Rajendran. It is very difficult that a administrator becomes a scholar. And from your particulars, I see that you are not only administrator but a scholar also.
Thank you.
I would like to thank the head of the department and particularly our young friend, Raja Ramchandran. Today, at least 3 universities are organizing conferences for Srinivasa Ramanujan. That's why I wanted me to give the lecture. So it was impossible to give lecture at 3 places at the same time. So I have ordered my lecture. And this is a tribute to Srinivasa Ramanujan. Please go ahead and share that.
Now I request our Vice Chancellor of our university to give the presidential address, sir.
Okay.
Thank you, Dr. Raja.
Sir, thank you, sir.
In fact, it's a very warm good morning to everybody. In fact, I must say, it's a pleasure for me to be here sharing this platform with Professor Ravi Agarwal, who is President Chairman at the Department of Mathematics, Texas A&M University, USA. And we have with us other distinguished professors who have joined our webinar. Alongside has been organized by 2 centers of Alagappa University. One is Department of Mathematics, and the other is named after the great mathematician Srinivasa Ramanujan's Center of Mathematics. So Dr. Anbaragan, who is the head of the Department of Mathematics of our university, Dr. Raja, the dynamic coordinator of Ramanujan Center for Higher Mathematics. and also scholars, students, and all those who have joined this morning for this program. And every year on 22nd December, we celebrate the birth centenary of the legendary mathematician Srinivasa Ramanujan. And in fact, he is an enigma because as in the introduction, Dr. Raja as well as Professor Anbaragan said, I belong to the other side of the coin or table because diametrically opposite to mathematics is history. In fact, those who have read the biography of, say, Srinivasa Ramanujan, in his matriculation examination, he passed with high, colors. At the same time, when he went for intermediate, there was an inquiry committee because he went to Cambridge and then Trinity College with the help of Hardy. And there he was conferred upon the BA degree. And at the same time, his fame rose throughout Europe, not only in England, but also across the continent. And at the same time, then the British government tried to investigate how is it that such a individual was not noticed in Madras, particularly in Tamil Nadu. And then there was an inquiry, a letter was sent to the registrar of Madras University to find out what happened to the examination written by Srinivasa Ramanujan. And the result is reply was given by the registrar of, that was a British professor who was holding the chair of position of registrar. He wrote back to the government saying that Srinivasa Ramanujan scored, 35 marks in English out of 200, whereas he has to score 70 marks. Whereas in mathematics, out of 150, he scored 85. These are on record. But he did not present himself for psychology and history. He did not attend the examinations, in fact. So, in fact, he is an enigma, I say, because Srinivasa Ramanujan did not have the lineage of a very affordable family because his father was working in a textile shop, helping the textile owner, writing accounts there from the Erode Taluk, as well as Erode district. And at the same time, he did not have a very good education in the sense colleges of repute or institutions of repute. He was studying in a very, schools where ordinary people went. Later on, he went to the Government Arts College, Kumbakonam. And after that, he went to Chennai, where he studied for a year or two at Pachayappa's College, Chennai. But he did not have any of the advantages of the lineage, either by money or position or good education for that matter. But at the same time, he was a self-taught man and he became a luminary, but not recognized in his own country, contemporaneously speaking. But there are riddles in history. There are riddles in history. Because if you go to Government Arts College, Kumbakonam today, there is a portrait of Srinivasa Ramanujan, who did not pass the examination, most importantly. Srinivasa Ramanujan, he is not an ordinary person, a routine person who passes all the examinations and goes for a job. But whatever he produced at that time, I think the times where he was ahead of the times. In a way, they wanted something mundane, routine from Srinivasa Ramanujan. But unfortunately, his brilliance and his genius was unrecognized. And yet, later on, after independence, after a long time, the government of India, they established a portrait, particularly at Port Trust, where he worked from 1912 onwards till he went to, Cambridge. And at the same time, the college where he studied, that is Kumbakonam Arts College, there also there is a half bus size statue is available. as you enter the college, you can see. So this is again an enigma. Enigma in the sense, not a routine student who obtained a first class in his degrees, but at the same time, here is Ramanujam, who is really, revered and also followed as a model by many of the mathematicians in India. In fact, if you go through the life of Ramanujam, what strikes me more as a historian of science, what I find in Ramanujam is that during his school days, he got interested in mathematics at the age of 12. He got hold of S.L. Dhoni's plain trigonometry book. And mind you, at the age of 12, without anybody's help, he solved all the problems. Later on, with the government college library, he obtained course Synopsis of Elementary Results in Pure Mathematics, and which caught his attention greatly. And I must say that he was fully involved in learning mathematics from 1903 to 1910. He was really wandering here and there. In between, in 1909, he got married to Janaki, and he was forced to seek for a job. And here, he met three individuals. One was P.V. Iyer, who was a deputy collector and also the founder of Indian Mathematical Association. And later on, P.V. Iyer, noticing the brilliance of Ramanujam, he thought he should continue his studies. So he reintroduced him to P.V. Seshu Iyer, who was a professor for Ramanujam at Kumbakonam College. And P.V. Seshu Iyer again understood the mentality of Ramanujam, who was immersed in, mathematics, because it has been testified by his wife at a later date, when some of the biographers went and met Mrs. Janaki, who was the wife of Ramanujam. She used to say, Ramanujam did not even took interest in eating, normal eating. And in fact, both Mrs. Janaki and Ramanujam's mother forced Ramanujam to take food during normal course of day. All the time he was thinking about mathematics, he was doing mathematical sums. And that is also later on when he went over to England at Cambridge for the deterioration of his health, and because he was not evincing a lot of interest in, tendering himself, because he was a strict vegetarian and vegetarian food was not available all that easily at that time. And he has to cook for himself, because even at home in Kumbakonam, he was not taking interest in eating normal food. So he neglected his health, that later on proved to be fatal. So what we found in P.V. Seshu Iyer, he introduced to a landlord. His name was R. Ramachandra Rao of Nellore. And, there is a diary of Ramachandra Rao who recounted how he met Ramanujam. Ramanujam entered the room of Ramachandra Rao at Nellore, and with a notebook in his hand. It's a worn-out notebook in his hand. And Ramachandra Rao took a deep glance at Ramanujam. He found that he was unshaven, not wearing, iron cloths, but he was carrying this notebook. That is a proverbial Ramanujam. But what caught his attention was the spark in the eyes of Ramanujam. A look at Ramanujam's face, Ramchandra Rao recalls that he was caught by the, brilliant eyes of Ramanujam, and then he offered him help so that he continued to, do mathematics. But Ramanujam felt it was not correct to survive on the, money of, Ramchandra Rao. Hence, in 1912, if I remember correctly, he went to Chennai, and there he got a job as a clerk at Madras Port Office. In fact, there he got the, introduction of two people One is S.N. Iyer, the then chairman of Madras Port, and Sir Francis Spring. Both of them took a great interest in Ramanujan. And these individuals, in fact, prompted Ramanujan to write a letter to Cambridge to G.H. Hardy. And this famous letter was written on January 16, 1913 by Ramanujan. There Ramanujan gives his own account, what he introduces himself to Hardy. And I would like to just quote few lines from here. I beg to introduce myself to you as a clerk in the accounts department of the Port Office at Madras on a salary of £20 per annum. And after leaving school, I have been employing the spare time at my disposal to work at mathematics. I have not trodden through the conventional regular course which is followed in a university course. And after seeing the letter, Hardy put the letter aside. It was his associate, J.E. Littlewood, who drew the attention of Hardy once again. And after seeing that letter, going through the letter once again, where a number of mathematical problems were written by, say, Ramanujan. And Hardy says, I had never seen anything in the least like them before. A single look at them is enough to show that they could only be written down by a mathematician of the highest class. And that is how the journey of Ramanujan continued at Cambridge. And he went on to produce, in fact, a very magnum opus, I must say, joining Hardy, the theory of numbers, and then Ramanujan's tau function, probabilistic number theory. And then Hardy and Ramanujan, they introduced what is called the circle method. And, all in all, I must say, he published 37 papers, 3 notebooks containing more than 3,000 theorems. And also his last notebook was recovered. And there are other unpublished papers which he brought from Cambridge, but it was once again lost because that was after his demise, it was taken away by previous year. We do not know what is the position of those papers. And also, 1 year he worked as a scholarship-funded fellow at Madras University before he went on to, say, England. And there he produced certain reports. This was a customary thing by any scholar who is working on a fellowship for every 6 months. And these reports are also not found. But however, I must say, at the end, Hardy, at the end, he says, no, if you want to find what is the position in the scale of 0 to 100, if you want to, say, place myself, I would say I can give myself a score of 25. This is the words of Hardy. And his collaborator, J.E. Littlewood, 30 out of 100. And the great German mathematician D. Gilbert, 80. And Ramanujan, 100. And this is how, say, his own mentor, Hardy, rates himself against Ramanujan. But what is perplexing is that Ramanujan's work, I think, did not receive the attention that he should have received in India. For example, K.G. Ramachandran in Bombay, except K.G. Ramachandran in Bombay, and came Venkatachala Iyengar in Bangalore. They worked on Ramanujan's work. In fact, our own university there are many universities and many centers which are named after this great mathematician. And I must say, the youngsters should draw inspiration from, not only inspiration from Ramanujan, but also they try to say work on the theories and the theorems of Ramanujan, though they were classical in nature, and we must contribute, say, side by side. I think he is much more known, known across Europe as well as in USA than in India. That was the statement made by one of the biographers. But it is true that in India now, after independence, attention has been paid to Ramanujan and Ramanujan's, say, notebooks, and all of them have been published by Government of India. and one notebook has been handed over to the widow of that is Mrs. Janaki, and especially the youngsters, like National Mathematics Day, when we are celebrating and remembering Ramanujam, should also contribute richly to the sphere of mathematics. I'm sure this will inspire all the participants who have joined us today for this program. I am really thankful to Professor Ravi Agarwal for taking his time at this odd hour there back in USA to join this program. Thank you very much.
Thank you very much for your valuable presence beyond your busy schedule, sir. We all know how much you love and interested in mathematics. Your talk is always a fruitful one to our mathematics community as well. Once again, I wish to thank you very much for joining with us on this wonderful occasion, sir.
Thank you.
Now I request our chief guest and the great mathematician, Professor Ravi P. Agarwal, sir, to talk about a few words about Ramanujam and share some.
Well, your Vice Chancellor has already said much more about Ramanujam than I know. But I should say that there is a book entitled The Person Who Knew Infinity. And you will find every detail about Ramanujam, about his family, about his childhood, about his education, about his work in Britain and back to India, and what type of life he was living, and what happened after his death also. So it is really a sad story, but what is most important that God sent him to do certain things, and his work was over. He just went away. So this is what is the nature, and my lecture you will find some details about his work, and I have a student who did work on Ramanujam's work, and he is professor in Singapore now. So we have doing some work in number theory, but not the type of work he was doing, because it is very, very difficult to get something what he has done. So if it is time, please start the video what I have sent you.
Thank you so much, Professor, for sharing your thoughts and views to our university people, and also most of the people from abroad also, they are joining with us to see your lecture via YouTube and as well as via Google Meet. Thank you once again, Professor.
Thank you, Professor. Thank you, Professor.
Thank you, sir. Thank you.
I'm sitting here.
Okay, sir. Unbroken, sir.
Yes.
Sir, thank you.
Okay. So I thank Professor, most respected Vice Chancellor, Professor N. Rajendran, for proceeding over this function. Next, I would like to extend my thank to Professor Ravi Agarwal, Professor of Mathematics, Texas A&M University, for his inaugural address for this National Mathematics Day celebration. And also, I thank each and every one from distinguished professors from various institutions all over the world. So I thank the participants and my dear students. So once again, I thank one and all for this joining with us for the National Mathematics Day celebration. Thank you once again. Thank you.
Thank you. Thank you, Professor.
Thank you, sir. Thank you, sir. Thank you so much, sir. Now I request all the participants to stay to listen to the lecture on the topic, "Are we prepared to accept the reality?" by the great mathematician, Professor Ravi P. Agarwal, sir.
In this lecture, an attempt is being made to convince the world, especially we Indians, that in reality Bharat, that was the name of India and it is called the Greater India, is the origin of mathematics. This will correct what most of the historians of mathematics have claimed in their books, and we have accepted it religiously. In fact, it has been forced to accept whatever has been written in history books. There are three parts of my lecture. We will try to reassure that mathematics as well as proof cannot be defined. And the third part is to discuss some features of upapatis. This is a word in Pali, one of the very old languages in India, Sanskrit and Marathi languages, which has been recently discovered. So the origin of upapatis is not yet known. I begin with one of the most trusted book of Vibhuti Bhushan Datta. This book was published in 1932. The title of this book is The Science of Sulbas, a study in early Hindu geometry. On page 27 reads, the reference of the sacrificial altars and their construction is found as early as the Rig Veda, Samahita, before 3000 BC. It seems that the problem of the squaring of the circle and the theorem of the square of the hypotenuse are as old in India as the time of Rig Veda. They might be older still. Okay? That means the square root of 2 and the value of pi. They tried even before Rig Veda. 4 Vedas means wisdom, knowledge, or vision. Rig Veda, Sam Veda, Yajur Veda, and Earth Veda were codified by Krishna Dwaipayane or Sage Ved Vyasa. He was born in 3374 BC. Along with his disciples Jaimani, Paila, Sumantu, and Vaishpayane. 4 Veda consists of 4 parts. Each Veda consists of 4 parts: the hymns, the rituals, theologies, and philosophies. Arthur Schopenhauer, one of the greatest German philosophers and writers, he says, in the whole world there is no study so beneficial and so elevating as that of Upanishads. It has been the solace of my life and it will be the solace of my death. They are the product of the highest wisdom. Vedas are the most rewarding and the most elevating book which can be possible in the world. Niels Bohr, Nobel laureate in physics, for his theory of atomic energy. He says, I go into Upanishads to ask questions. Stephen Knapp, he has written two books, The Secret Teaching of Vedas, it published in 1993 in Bombay, and another book he has written, Proof of Vedic Culture's Global Existence. This was published in 2009. During Vedic period, at least 5,000 years ago, it was known that the distance of the moon and sun from the earth are 108. This is a very sacred number in several Eastern religious and cults, times the diameter of these heavenly bodies, respectively. The observed values are 110.6 for the moon and 107.6 for the sun. Hindus also discovered what is known as the precession of the equinoxes, and their calculations such an occurrence takes place every 25,827 years. Our modern science, after labors of hundreds of years, has simply proved them to be correct. Jean Vallée, great French astronomer and politician, noted for his computation of an orbit for Halley's Comet, the motion of the stars calculated by the Hindus before some 4,500 years vary not even a single minute from the modern tables of Cassini and Mayer. John Wheeler, eminent American physicist, the first one to be involved in the theoretical development of the atomic bomb and the first to coin the term black hole, who later occupies the chair that was held by Einstein. I like to think that someone will trace how the deepest thinking of India made its way to Greece, and from there to the philosophy of our times. So this is the other way around. Normally it is Greece to India, but here it is India made its way to Greece. The meaning of the word sul is to measure, and geometry in ancient India came to be known by the name Sulba or Sulba. The Sulba Sutras are the appendixes for the four Vedas. Only 7 Sulba Sutras are extant, namely for the sages who wrote them. Apastamba, Buddhayana, he was born 3200 BC. Katyayana, Manva, Maitrayana, Baraha, and Vidula. The 4 major Sulba Sutras, which are mathematically the most significant, and those composed by Buddhayana, Manva, Apastamba, and Katyayana, these Sulba Sutras contain a large number of geometrical constructions for squares, rectangles, parallelograms, and trapezia. The problem of solving quadratic equation of the form ax squared plus bx plus c is equal to 0, several examples of arithmetic and geometric progression, a method for dividing a segment into 7 equal parts, solutions of first-degree indeterminate equations, and without any proofs. This is important, without any proofs. Remarkable approximations of square root 2 and pi. In the book India in Greece, see the title, India in Greece. published in 1852 in England by the Greek historian Edward Pocock, reports that Pythagoras, who taught Buddhist philosophy, was a great missionary. His name indicates his office and position. Pythagoras in English is equivalent to Pythagoras in Greek and Buddha Guru in Sanskrit, which implies that he was a Buddhist spiritual leader. Note that Lord Gautam Buddha was during 1807 BC. I will suggest strongly, please correct Lord Buddha's time, 1887 to 1807. Historians have misled the world by claiming that he flourished around 450 BC. Francis Voltaire, he's not the same Voltaire who was a mathematician. One of the greatest French writers and philosophers. I'm convinced that everything has come down to us from the banks of Ganga, in English, Ganges. Astronomy, astrology, and spiritualism. Pythagoras went from Samos to Ganga 2600 years ago to learn geometry. He would not have undertaken this journey had the reputation of the Indian science had not been established before. Thomas Eliot, American-British poet, novel laureate. In 1948, he wrote, "I am convinced that everything has come down to us from the banks of Ganga. Astronomy, astrology, spiritualism, etc. It is very important to note that some 2500 years ago, at least Pythagoras went from Samos to Ganga to learn geometry, but he would certainly not have undertaken such a strange journey had the reputation of the Brahmin science not been long established in Europe." According to historians, Pythagoras also went to Egypt and Babylonia in search of knowledge. Some prominent historians of mathematics, for example, van der Waerden, Stirling, and Thomas Heath, have suggested that Egyptians had no knowledge of Pythagorean theorem, which is not true. See Berlin Papyrus 6619 and Cairo Mathematical Papyrus, unearthed in 1938 and first examined in 1962. Of course, there is a sufficient evidence that Pythagorean's theorem was known to Mesopotamians. CYMC 7289 and Plimpton 322, written between 1719 and 1750 BC. However, our two quotations strongly suggest that Pythagoras learned about Pythagorean theorem and triples probably in India. For their origin, pattern, extensions, astonishing directions, and open problems, I have written very recently 2 papers. In these 2 papers, I have provided a lot of details, and if any one of you are interested, I'll be happy to send you the PDF files of these ones. I'm sure that you know my email address. Now, India is considered the land of numbers. She has produced several leading number theorists such as Srinivasa Ramanujan. He was the youngest who became Fellow of Royal Society in 1918. He was one of the greatest intuitionalists. In the world, although there are about 4,000 languages, of which several hundred are widespread, there are only several dozen alphabets and writing systems that represent them. However, we can safely say that there is but one single place value system that uses 0 and 9 numerals, symbolically 0, 1 up to 9, by which any number can be expressed and understood rather easily. Please see the next sentence, which is very powerful. This gift of India has truly united the universe in the language of numbers. It is worth noting that there is hardly any aspect of our life in which numbers do not play a significant, though generally hidden, part. In 1875, George Thibaut translated a large portion of Sula Sutras, which showed that the Indian priest possessed significant mathematical knowledge. Thibaut was a Sanskrit scholar, and his principal object was to make the mathematical knowledge of the Vedic Indians available to the learned world. He firmly believed that Hindus had knowledge of irrationality, in particular of square root 2. In fact, in Apastamba, there is a discussion of the irrationality of pi. Of course, there is no proof, but there is a discussion that square root 2 cannot be computed exactly. Pi cannot be computed exactly. A long paper rather, I'm writing on this topic, and if you are interested, write to me, I will be happy to say. Acharya Charak and Acharya Sudhur. Charak has been crowned the father of medicine. His Charak Samhita is considered to be an encyclopedia of Ayurveda. Ayurveda is very long, it has a long history, which means science of life. In this work, there is also an interest in permutation and combination. His treatise, Suhurt Samhita, states that 63 combinations can be made out of 6 different rasa: bitter, sour, salty, astringent, sweet, and hot. By taking the rasa one at a time, rasa is taste, 2 at a time, 3 at a time, and so on. This solution of 63 combinations can be checked. This is what is the equation, and you can check that the sum turns out to be 63. So 600 BC, Pingala, about 500 BC, was the author of Chanda Shastra. Chanda is actually moon. The Sanskrit book on meters or long syllabi. Pingala was the younger brother of the great grammarian Panini, the author of the famous treatise Ashtadhyayi of 5th century BC. Sanskrit words are very difficult. Pingala presented the first known description of a binary numeral system. I'll repeat this one again. Pingala presented the first known description of a binary numeral system. He described the binary neural system in connection with the listing of Vedic meters with short and long syllabi. His work also contains the basic ideas of mantra menu and menu prasthara, concepts that are inappropriately now known as Fibonacci numbers and Pascal's triangle respectively. His book Chanda Shastra contains the most known use of zero, indicated by a dot. In this book, he also explored the relationship between combinatorics and musical theory, which was later reproduced by Marcinin. Around the end of 10th century, Halayudha, about 975, produced a commentary on Pingala's Chanda Shastra, in which he introduced a pictorial representation of different combinations of sounds, enabling them to be read off directly. Halayuda's Meruprasthava or pyramidal arrangement provides the binomial expansion of a plus b to the power n, where n is equal to 1, 2, 3, and so on. Let us see what Laplace, I am sure you have heard his name, French greatest mathematician, philosopher, and astronomer. It is India that gave us the ingenious method of expressing all numbers by 10 symbols, each receiving a value of position as well as an absolute value. A profound and important idea which appears so simple to us now that we ignore its true merit. Albert Einstein, one of the greatest scientists, philosopher, Nobel laureate for his theory of relativity, we owe a lot to Indians who taught us how to count, without which no worthwhile scientific discovery could have been made. Androville, French. He fell in love with mathematics, Sanskrit literature. By the age of 16, he had read Bhagavad Gita. This is one of the religious books which every Hindu he should know. In the original Sanskrit, wrote in 1884, what would have been Fermat's astonishment if some missionary just back from India had told him that his problem had been successfully tackled by native mathematicians almost 6 centuries earlier. In fact, Brahmagupta, born 30 BC, and Bhaskara II, working 486, had addressed themselves to some of Fermat's problems long before they were thought of in the West, and had solved them thoroughly. They have not held a proper place in mathematical history or received credit for their problems and methods of solutions. Ancient astronomers' texts such as Surya Siddhanta and its commentaries contain trigonometric formulas. Bhaskara 123 BC, he writes sin x as 16x pi minus x divided by this factor. So this is the approximation formula. Brahmira, sin x is cosine pi over 2 minus x, sin square x plus cosine x square x is equal to 1, now known as Pythagorean identity and half angle formula. And Bhaskara too developed this trigonometric formula which we teach in high school. Important exact formula for finding the area of a triangle having sides ABC, known in the literature as Heron of Alexandria, 75 AD, was stated earlier by Bhaskara 1. A as square root S minus A, S minus B, S minus C, where 2S is A plus B plus C, and ABC are the sides, of course, and um, this formula was later generalized by Brahmagupta um, for finding the area of a cyclic quadrilateral and its sides ABCD. So this is what is the formula. This formula has been named by Snell's formula. So you can see how much injustice has been done by historians. Perhaps they didn't see what was existing outside Europe. The term tangent was coined by Leibniz in 1684, which has been credited solely to Newton and Leibniz. For Newton, the calculus was geometrical, while Leibniz took it towards analysis. However, the concept of a derivative had been developed almost 1200 years before Newton and Leibniz by Bhaskara II, who provided differentiation of the trigonometric functions. For example, in modern notation, he established delta sine x is cosine x delta x. Bhaskara II also gave a statement of Rolle's theorem, concluded that the derivative vanished at a maxima, and introduced the concept of instantaneous motion of a planet in his collection Siddhanta Shiromani. Then in the 14th century, Madhva invented the ideas underlying the infinite series expansion of functions, power series, trigonometric series of sine, cosine, tangent, and arctangent. These series have been credited to James Gregory and Brooke Taylor, and Newton, of course. Rational approximations of infinite series, tests of convergence of infinite series, the estimate of an error term, and early forms of differentiation and integration. You will never find these things in any book written by Europeans. Madhva fully understood the limit nature of the infinite series. This step has been called the decisive factor onward from the finite process or procedures of ancient mathematics to treat their limit passage to infinity. Actually, calculus of Newton and Leibniz based on limit only, which is in fact the kernel of modern classical analysis. Parmeshwara, in between 1370 and 1460, disciple of Madhva, he stated an early version of the mean value theorem in his Lilavati Bhasha. This is considered to be one of the most important results in differential calculus and was later essential in proving the fundamental theorem of calculus, which shows the inverse character of tangent and area problems. Torricelli was the first to understand the fundamental theorem of calculus geometrically, and this was extended by Gregory and Barrow, established a more generalized version, and finally Newton completed the mathematical theory. After doing this, this became Newton's calculus. Neil Canton. I will just show this series. This series was known to Neil Canton, okay? And this series today is known as Gregory-Leibniz series in the literature. I'm sure you have heard the name of L'Hopital's. and it is claimed that he wrote the first textbook on differential calculus. Nowhere it is mentioned that Jastha Devan, around 15 to 1600, wrote the calculus text Yukti Bhasha in a local language of Kerala, Indian state Kerala, about 150 years earlier. In mathematics, a set is defined as a collection of objects or elements, and set theory is considered to be a branch of mathematical logic. It has been documented that George Cantor introduced set theory to the mathematical world in 1874. However, during 200 to 875 AD, the Jain school of mathematics in India utilized the concept of sets. In their work, the Jainis introduced several different types of sets, such as cosmological, philosophical, karmic, finite, infinite, transfinite, and variable sets. They called the largest set as omniscient set, and the set containing no elements was called as the null set. They also defined the concept of a union of sets and used the method of one-to-one correspondence for the comparison of transfinite sets. In order to determine the order of comparability of all sets, they considered 14 types of monotone sequences. Thus, Cantor alone, this is the most polite way I could write, thus Cantor alone is not the founder of set theory. His major contribution was the mathematical systematization of set theory, now known as naive or non-axiomatic set theory, and the modern understanding of infinity. Today, set theory is woven into the fabric of modern mathematics. In fact, the language of set theory is used to precisely define nearly all mathematical objects. Now, the word mathematics was coined by Pythagoras. It meant a subject of instruction, and its first part, math, comes from an old Indo-European root that is related to the English word mind. The Pythagoreans grouped arithmetic, astronomy, geometry, and music together, and for several centuries, mathematics referred to only these four subjects. After Pythagoras, several different definitions of mathematics have been proposed. Each one tries to define mathematics with a specific context in mind. For example, mathematics is like drafts in being suitable for the young, not too difficult, amusing, and without peril of the state. This is the definition by Plato. Mathematics is the study of quantity. This is the definition by Aristotle. Now, I can continue. Mathematics is the science of order and measure by Descartes. Mathematics is concerned only with the enumeration and comparison of relations. This is Gauss. Mathematics is the science of what is clear by itself. Jacobi. I can continue. Several different definitions of mathematics have been given. Mathematics is a branch of logic, that kind, and so on. Bernard Russell, mathematics is a subject identical with logic. Mathematics is the art of problem solving, George Polya. Now, there are several definitions which I can continue, but there is no time. Okay. Now, what I want to jump is something which is, as a mathematician, you will not like to see this one. Let me just move. This still continues. So this is by Sir William Hamilton, not the mathematician, but the Scottish philosopher, logician, and metaphysicist. Viewed mathematics in a way that may be constructed as a cruel attack on mathematics and hence on mathematicians. Mathematics frees and parts the mind. An excessive study of mathematics absolutely incapacitates the mind for those intellectual energies which philosophy and life require. Mathematics cannot conduce to logical habits at all. In mathematics, dullness is thus elevated into talent, and talent degraded into incapacity. Mathematics may distort, but can never rectify the mind. I don't think any mathematician will like to hear this. Now, the following story, known as the blind man and the elephant, this is from Buddhist Sutra, is relevant to our attempt to define mathematics. Several prominent citizens were engaged in a hot argument about God and the different religions and could not come to an agreement. So they approached Lord Buddha to find out what exactly God looks like. Buddha asked his disciple to get a large majestic elephant and 4 blind men. He then brought the 4 blind men to the elephant and told them to find out what the elephant would look like. The first blind man touched the elephant's leg, reported that it looked like a pillar. The second blind man touched its tummy and said that an elephant was an inverted ceiling. The third blind man touched the elephant's ear and said that it was a piece of cloth. The fourth blind man held on the tail and described the elephant as a piece of rope, and all of them ran into a hot argument about the appearance of an elephant. The Buddha asked the citizens. Each blind man had touched the elephant, but each of them gives a different description of the animal. Which answer is right? All of them are right, was the reply. Why? Because everyone can see part of the element. They are not able to see the whole animal. The same applies to God and to religions. No one will see him completely. By this story, Lord Buddha teaches that we should respect all legitimate religions and their beliefs. This famous blind man episode is not meant to disrespect any mathematician. We state it only to point out that any definition of mathematics, however elaborate or epigrammatic, will fail to lay bare its fundamental structure and the reasons for its universality. This is the statement from Herman Weyl. That means, in fact, the definition of mathematics continues to change with time and innovation. So this is what is the best we can say. I'll read this one again. The definition of mathematics continues to change with time and innovation. Okay. Now, what is a proof? A proof is an explanatory note that the human senses can perceive and that leads the mind and intellect to establish the validity of a fact or argument. Proofs express subjective truth, not universal truth. Since humans have limited perceptive power, there are innumerable subtle assumptions that must be made during the process of proof, which are beyond human intellect. Therefore, any proof can never be exact. This is why we accept whatever truth can be established within our human limitations. Yet the great sages and rishis of history possessed in samadhi state. One has to define what is a samadhi stage. Extraordinarily subtle insight as well as unique experiences which led them to establish certain truths. These are known as empirical theories and are simple, well-founded empirical generalizations or laws about the properties and behaviors of object that are obtained by examining a large number of instances and seeing that they conform without exception to a single general pattern. These theories could never be questioned and have withstood the test of time. One expects such theories because of his total faith in the wisdom of these sages, or because he believes this is to be primary or the sole path to knowledge. If you read this carefully, you will find that mathematical proofs are also not defined. In fact, mathematics is considered equivalent to proof, or without proof, mathematics is not mathematics. Since mathematics is not defined, proof is not defined. Okay? I gave a long lecture on proofs cannot be exact. Let me just give you one or two examples. It should be noted that proof has different shades of meaning depending upon the field in which it is considered. For example, within the legal system, the burden of proof in a civil court is preponderance of evidence, whereas in a criminal court, it is beyond a reasonable doubt. In the scientific world, physics, chemistry, engineering, truth is established by experiments. In the business world, statistical analysis of data are performed by conclusions and derived. In political or international matters, organizations or group of individuals are entrusted with finding the truth of a given issue, and they come up with their conclusions based on classified intelligence reports, site visits, interviews, and other such activities. In a religious sense, this is again important. In a religious sense, proof is difficult to even describe. In scientific measurements, due to uncertainty, the absolute truth cannot be found, although we may get extremely close to doing so. Okay, I will just move further. I will go back. A proof of a mathematical statement is a logical argument that shows the statement is true according to certain accepted standards. It is believed that the idea of proving a statement began about the 5th century BC in Greece. Initially, philosophers developed a way of convincing each other of the truth of particular mathematical statements. They used definitions and axioms to do this convincing. Over time, these ideas were collected and organized in 13 books of Euclid, Elements of Mathematics. Recent research on Indian mathematics shows that there were other methods of investigating mathematical ideas other than commonly accepted proof methods as described by Euclid. I'm going to skip this part. This is about Upapatis. Its origin is not yet known. Now, there is a widespread notion that once something has been proved mathematically, then it is as it were set in stone that we have mathematical proof that remains true for all time. Not so, says James Meyer. According to him, a proof is always dependent on whatever system of assumptions and rules of inference used to create the proof. He writes that most mathematical proofs that anyone will encounter fall a long way short of idealistic concepts. So, what is the conclusion? The conclusion is you write a paper, it is published in a good journal, you are happy. But your happiness is very temporary. Within weeks, within months, within years, somebody will generalize it and you will be forgotten. That is what is the meaning of this one. Okay? And that's what precisely is happening. In last 100 years, can you name even a single theory? I'm not referring to computer science. I'm not referring to medicine. In that, these two branches, the research has been enormous. Okay? But in mathematics, it is all generalizations, extensions, combining the two different fields. That is what is going on. Let me read the last paragraph. While the definitions of mathematics and proof continue to change with time and innovation, our students hate proofs, but give them some result which they can put on computer, they are very happy. Okay, so I'm very sure after few years, the definition of mathematics and the definition of proof will be very different than what it is today. So let me continue. While the definitions of mathematics and proof continue to change with time and innovation, mathematics rewards its creator with a strong sense of aesthetic satisfaction. It helps us understand man's place in the universe and enables us to find order in chaos. Under certain axioms, mathematics is the most absolute, everlasting, precise, significant, and universal subject. It is perceived as the highest form of thought in the world of learning. No doubt, mathematics is one of the greatest creations of mankind. If it is not indeed the greatest, mathematics will live forever. That means if you have done PhD, sooner or later you will get job somewhere. There are only 2 references. This monograph I published in 2014. Till today, I have not received even a single criticism. I have corrected in this one the chronology, and I have shown very clearly that Greece was not the starting point or the origin of mathematics. This is another book. The whole idea started after reading this book carefully. So let me show my picture once more. How to go back? Okay. And then share camera. Okay. Just the fraction. Okay.
Beyond that, you are spending much more time with us, and few of them are willing to talk to you, Professor. I request all the participants, a few of the participants, to ask any questions, raise questions
Sure.
to our chief
First,
guest and a great mathematician.
First, I will say, if you want, I will send you my full lecture.
Yes,
Okay.
Professor. Yes, Professor.
Yeah, so that you can circulate. Okay.
Yes, definitely, Professor.
I'll send it tomorrow. Yes.
Yes,
Please, you can ask me anything.
So unmute your mic and ask if you want.
Yes.
Pardon me?
Sir, it is me, Ganesh Murthy. I like to give a comments on your lecture. I'm
Sure.
speaking from Alagappa University, Karaikudi. I'm being the professor here. And see, you described the history of mathematics, more specifically about the Indian mathematics. You concentrated on 2 things. One, this is about you in the first slide itself mentioned that it is you are going to reassure that the mathematics as well as the proofs cannot be defined, and I just wondered that I could understand that mathematics cannot be defined. I also used to talk the same thing in my classrooms as a teacher. But I understood that the proofs cannot be defined. Of course, precisely I understood your sense. Very interesting lecture, sir. And as a teacher, I like to ask you one thing. See, you talked about Pingala and Chanda Sutra's his book, and he mentioned that you could find the first known use of zero.
Yes.
Yeah, first known use of zero. See, I like your explanation for the phrase use of zero, so that we can have the definition for the zero.
Yeah, it is the place value. It is not that actually in Hinduism, the word shunya is known from generations. I mean, see, 2 words, shunya and ananta. Shunya is 0 and ananta is infinity. Even the sign infinity, perhaps it will be interesting to know, the sign of infinity, it was given by Wallace, the teacher of Newton. But from where it came, that will be really surprising. That came, you see, Lord Vishnu is lying on a snake which is coiled, and that is Ananta, and it has come from there. Okay, so these things were existing in our religion from a long time. but the place value system was not. So place value was started from this book. Okay,
Yes, sir.
that is what is the answer.
Yes, sir. Yes, sir.
Actually, if you are interested, send me your email. I will send you the book.
Okay.
I have a PDF. I have a PDF file of the book.
Okay.
Okay.
Sir. Okay. Okay. Thank you. Thank you. May I ask one more question, sir?
Sure.
This is,
Sure.
yeah, this is regarding your title. Say, are we prepared to accept the reality? Once
Yes.
again, when we come to the reality about the history, first thing, reality about mathematics, definition of mathematics, and the reality about the definition of the proofs. Okay. Do you mean all these three simultaneously?
No, you see, if you start comparing
Yes, sir.
with whatever history books are existing,
Yes, sir.
then you will find whatever I have tagged is nonsense. Okay? Why? Because they have written whatever was existing only in Europe.
Yes, sir.
You will find that in history books
Yes, sir.
about Indian mathematics or Chinese mathematics,
Yes, sir.
just maybe 4 pages, 6 pages, or sometimes even footnotes.
Yes, sir.
It was completely ignored.
Yes,
Why it was ignored? Either they didn't bother to see what is existing. You see, there is a general feeling every good thing which has come to India, it has come from Europe.
Yes, sir. Yes, sir. Of course.
Yeah. So that's what is my. I mean, my title is not about the reality of what I have written. My question is that the reality is this: that whatever is started, it is started from India.
Yes, sir.
So when I say to somebody, immediately somebody will ask me, what is the proof? Now, what type of proof you want? What type of proof you want? See, I'll just give one example. You will find in the literature about King Ashoka.
Yes, sir.
Okay. And it is written very clearly that at the later stage, when he saw so many people died in the war,
Yes, sir.
he adopted Jainism.
Yes, sir.
Okay, sorry, Buddhism. That means certainly Buddha was born before Ashoka.
Yes, sir.
Otherwise, how can he adopt Buddhism?
Yes,
Right?
of course.
Now, that started bothering me. So I started reading books, not about the history of mathematics. I started reading books by saints, written by saints. And I discovered that Buddha was born not in 486 BC, but much earlier. So what has happened, these people, they have pushed everything 1500 years. Everything. Okay. So whatever was existing for 1500 years, there is no history of India.
I see.
Everything was pushed off.
Yes, sir.
So you send me your email address. I'll send you the book, and tomorrow I will send Raja the complete lecture. And if you have any other question, you can write to me. You can write to me, and I will try to answer. Okay.
Okay. Thank you, sir. Thank you.
Okay. Okay.
Thank
Good
you.
night. Good
Thank you
night.
so much, sir. Thank you so much, sir. Thank you, sir. Thank you, sir. Any other questions? Any other questions from the participants? Okay, then thank you so much for being with us, sir, once again. And I thank our Vice Chancellor, beloved Vice Chancellor, Professor Rajendran, sir, for giving this nice opportunity for us to celebrate the National Mathematics Day. I didn't see Ramanujam, sir. On seeing Professor Ravi P. Agarwal, sir, it gives more inspiration for us to become like you, sir, in research and all other teaching.
There is only one secret.
Yeah.
And the secret is work hard.
Yeah. Thank you so much, sir.
It's 5 o'clock and I keep on working until I'm completely tired.
Thanks a lot, sir. And I thank the professors from various universities from around the world. Professor Siping Lim from Australia, Professor Gringrai from Thailand, and Professor Nadeshan Sir from IIT Guwahati, and Professor Ovidio Bhakta Sir from UK, and Professor Vajrali, Parpatama, Sasitan, and Tongchai from Thailand. I thank you all for joining with us to celebrate this wonderful event, and I thank our own fellow colleagues in our department and from other departments from our universities, and I thank our research scholars, my own research scholars, and all other research scholars from around the world, and I thank you all for joining with this great event. Thank you once again. Thank you, sir.
Okay.
Thank you, Professor.
See you, sir. See you, Professor.
Good night.
Good night.
Sorry.
Good night for you, Professor. Thank you.
Thank you, Professor. Thank you, Professor. Professor Ovidio, thank you so much. Thank you so
very
much,
much, Professor.
You have
Yes.
spent a lot of time with us whenever you organize a program.
It is my pleasure. I wanted to ask Professor Ravi Agarwal, what is reality?
Oh.
But I'll send this message in particular.
You can send the message or email to him directly, Professor.
Yes.
And he is willing to share the books and as well as his full video lecture to me, and I will forward the same to each and every participant. Our program is going on live in a live streaming on YouTube, and viewers are watching his lecture.
Yes, and happy Mathematics Day to India and to the whole world. It's very nice to celebrate together.
Thank you, Professor. Thank you so much, and an advance happy Christmas to you.
Yes, to everyone. Celebrate.
Thank you,
Thank
Professor.
you. Thank you, sir. Thank you.
Thank you, sir.
Thank you.
Thank you. Thank you, Professor. Professor Gringrai. Gringrai is there? Professor Gringrai. Professor Gringrai. I thank Professor Gringrai. Are you in line? Professor Siping Lim. Professor, are you there? I think. Professor Gringrai. How are you? Yeah, you just unmute your unmute your.
Yeah.
Yes.
Okay. Thank you so much for invitation.
Thank you, Professor. Now you are in Australia.
Yeah, because
Oh.
in Australia really hot today.
Oh.
Professor.
It is now very cold.
Yeah,
cold in India.
Really hot. In
Oh.
Australia really hot today is 40
Oh.
Celsius. Really hot today. Sorry.
Okay,
And
okay.
really great opportunity for the mathematician. But
Yes,
yeah,
Professor.
really thank you for very good experience to
Yeah, you spend them.
Professor Ravi Agarwal, very famous professor.
Yeah.
Very famous professor. Thank you for invitation in the Thailand mathematician. Sir.
Yes. Thank you so much, Professor. Thank you so much. Thank you so much for joining with us, and for
thank
our
you so
friends.
much. And thank you for the head department too.
Yes.
Vice chancellor too.
Okay, Professor.
And
Okay.
see you in next time.
Yes, sure.
Professor
Sure.
Raja. See you next time.
Thank you, Professor.
Thank
See
you.
you.
Bye bye. See you. Bye bye.
See you, Professor. Bye bye.